Welcome. We are going to look at section 6.3, using right triangle trigonometry to solve for a side of a right triangle. So we're going to use the three trig functions, sine, cosine, and tangent, to solve for a missing side when we are given an angle. So we know one of the smaller angles, one of the acute angles. The steps that we go through are listed, a four-step process right here. So we're going to label the sides in relation to the angle. We're going to choose the function that we need to work with, either a sine, a cosine, or a tangent, because those are the three that our calculator will work with. Once we've chosen the function to work with, we'll just pick one of the three. We'll set up an equation using that trig function, and then we'll solve the equation for that missing side. So we're going to do 4 examples. We're going to write an equation. These are our instructions. So right here are the instructions for our examples. Okay, so these are our directions. Write an equation. Maybe I'll write that over here. These are our directions on these examples. We have to write an equation using a trig function to solve for the x. And then we're going to find the measure. So we're going to find the measure of the side indicated, and we're going to round our answers to the nearest tenth. Okay, so let's do example 1. Example 1. I should leave those where I can see them. So I'm going to look at the angle that I'm given, the acute angle. So I have a 90-degree angle and I have a 54.7. And I'm going to label the sides in relation to that angle. So the 7 is across from the 90-degree angle, so it's the hypotenuse. That one really doesn't depend on the angle, the acute angle. It only depends on where the right angle is. Then the x, you notice the x is across the triangle, so that would be the opposite leg. Over here would then be the adjacent leg, but you know what? I don't care. I don't need that one. So that's the one that I'm not going to use. I want to work with the x and the 7, the 2 that are labeled. Okay, if I needed to, well, the x and the 7. So which trig function? So choose the correct trig function. So what we're going to do is this. We're going to cross this out, cross it out for a reason. I want to choose the trig function that works with the opposite and the adjacent, because I don't have the number for that, and I don't need to find that one. I want to work with the opposite and the hypotenuse. So we're going to use the sine function for this one. Okay? We're going to use the sine function because it is opposite over hypotenuse. So since the sine function is opposite over hypotenuse, we'll use the sine function. Right? Remember the so in SOHCAHTOA. So sine is opposite over hypotenuse. So I will use the sine function. All right. Let's set up our equation, which is the next step. So opposite over hypotenuse. That ratio is the sine of my angle 54.7 degrees. You can put the degree symbol on there or not. It's kind of up to you. How do we solve that for x? Well, what I want you to think about is, to get the x by itself, I really just need to move the 7. See that 7 right there in the denominator? I need to move that 7. So we need to ask ourselves, how do we undo division by 7? Well, we multiply by 7. So if I take both sides of this equation and multiply by 7, and this one time I'm just going to write it out this way, and then I probably won't do that again. We multiply both sides by 7. All right, this is a multiplication symbol. There's a multiplication symbol. We're multiplying both sides by 7. Okay, so on the left side, we just get x, because the multiplying and the dividing undo each other. And I'm going to find x by doing 7 times the sine of 54.7 degrees. So we're going to grab our calculator. So let's grab our calculator. And we're going to do 7. Oops, I need to do one important thing first. I'm going to check the mode. I am already in degree mode. If I'm not in degree mode, remember, you arrow down, arrow to the right, highlight the word degree, and push enter. Okay? And if degree is not highlighted, you need to make sure that you change it to degree mode. It needs to be in degree mode. All right, so we're going to do 7 sine of 54.7 degrees. And that is going to give us 5.7 when we round it to the nearest tenth. So x equals 5.7, and we're done. All right, example 2. We'll start out with the blue this time. All right, so the angle that we have to work with is this 60 degrees right here. There's the acute angle that we're going to work with. It might be useful to notice that if I wanted to, I could work with the angle down here because those two angles have to add up to 90 degrees. Yep. But the 60 is already marked, so let's just use it. So in relation to that angle, in relation to the angle that I'm working with, I'm going to label this, well, that's the hypotenuse no matter what. This is the opposite leg over here across the triangle from the 60, and this is the adjacent leg right there. Okay. Let's see. X is on the hypotenuse. 5 is the adjacent, and I know the adjacent. Oh, that's the one I'm not going to use. So choice of angle, or choice of function, sorry. Choice of the function that I'm going to work with, I'm going to use the cosine, because cosine is adjacent over hypotenuse, and I want to work with the adjacent and the hypotenuse. So we're going to set up our equation using the cosine. So let's write down our equation. Step 3, set up the equation. So we're going to have, for our equation, cosine of 60 degrees equals adjacent over hypotenuse, so 5 over x. And then the last step is solve that for x. It's going to be a 2-step process when the variable's in the denominator. You're going to multiply both sides by x to get the x out of the denominator, right? I have to get the x out of the denominator. The x has to be equal to something. I have to move it out of the denominator up to ground level. So we're going to take that and multiply both sides by x. So if you want to, at this point, you can say, okay, I'm going to multiply both sides by x. Okay, so I'm going to have x times the cosine of 60 degrees equals 5, because the dividing by x that's here and the multiplying by x that's here will undo each other. They're inverse operations. And then we're going to look at that one more time. X is not by itself, but I can get the x by itself if I divide, because that's x times the cosine of 60 degrees. To undo multiplication, we divide. So if I just divide both sides, I'll have it. So x equals 5 divided by the cosine of 60 degrees, because those are going to go away. That's going to turn into a 1. X times 1 is just x. Right? So those go away. You turn into a 1. Common factor. Take them out. So I'm going to go grab my calculator, and I'm going to do 5 divided by the cosine of 60 degrees. And that is exactly 10. So x equals 10. And we're done. Sometimes you'll have whole numbers and sometimes you won't. Depends on the angles. All right, let's look at example 3. Oh, we don't have a triangle. We get to draw our own triangle. So I'm going to draw a right triangle. That's going to be our first step, is to draw a triangle so we can see what's going on. So angle C is the right angle. Little c is across from capital C. I've got angles A and B. I'm going to put angle B up there. It doesn't really matter where I put angle B, as what matters is that I label things correctly in relation to angle B. So there's my picture. I switch colors here. I'm working with the angle B up here, this 44-degree angle. I need to label the sides in relation to that. Well, the hypotenuse is here, no matter what. It's across from the 90-degree angle. Oh, what is it I'm trying to find? I'm trying to find little b. I forgot to label that. See that? We're looking for little b. Where do we find little b? across the triangle from capital B. In other words, if I have angle B, little b is the opposite leg. So this is my opposite leg. Let me switch back to that color. And this would be my adjacent leg right here. Okay, which ones do I want to work with? I want to work with the missing B and the known C. So that's the one I'm going to leave out. So if I need the hypotenuse and the opposite side, that's going to be the sine function. So I'm going to use the sine function once again, because I'm working with the opposite and the hypotenuse. So now I'm to the point where I'll set up the equation because I've decided what trig function to use. Practice it. See if you can figure out what the equation looks like. Okay, we're going to do b divided by 4. That's the opposite divided by the hypotenuse. Remember, sine is opposite divided by hypotenuse. So we'll do b over 4 equals sine of 44 degrees. And then we will multiply both sides by 4 to get the b by itself. We undo divide with multiplication, so we'll multiply both sides by 4. So we'll have b equals 4 times the sine of 44 degrees. We'll grab our calculator and we'll do 4 times the sine of 44 degrees. And we get that b is 2.8. So b is 2.8. Right. Keep in mind that the legs should always be smaller than the hypotenuse. If you get something bigger than 4 for one of the legs, we've done something wrong. Right. All right, the next question, we're going to have to draw a triangle again. We have no triangle drawn, so I'm going to draw a triangle. Maybe I draw this one this way this time. And I put the right angle over here. So the right angle is at C. We'll put the A up here and the B down here. Doesn't really matter. This is 22 degrees. Maybe I'll switch colors there. So I'll put my 22-degree angle right here. Okay. I'll just leave the degree symbol off. 22 degrees. And then, so this is the angle. I'm going to label the sides in relation to that angle, that acute angle, that angle that's less than 90 degrees. So what is it I'm trying to find? I'm trying to find little b. Find side B. So side B is opposite angle B. It's across the triangle from it. So my little b is over there. So little b is over here. Little a is across from angle A. So right across from angle A is little a. And that one I know is 4. So I'm going to label that as a 4. Okay? And then let's label those in relation to angle B. What are they? This is the hypotenuse. This is the opposite leg because it's across the triangle. And this is the adjacent leg because it's right next to angle B. I don't want to work with the hypotenuse. I want to work with the opposite and the adjacent. So that's going to be the tangent. Tangent is opposite over adjacent. So when you're working with just the two legs, you're going to use the tangent function. So let me set this up with a tangent. Tangent of 22 degrees is going to equal a ratio. What ratio? Opposite over adjacent. It's right here, opposite over adjacent. Tangent is opposite over adjacent, so that's b over 4. And that's going to equal the tangent of 22 degrees. Okay? And then to solve that for b, we really just need to multiply both sides by 4. So we have b equals 4 times the tangent of 22 degrees. We grab our calculator. We come up with b equals 1.6. Now let's check that out for sure. 4 times the tangent of 22 degrees 1.6. Okay, 1.6. So there's our answer. B equals 1.6. And we are done. Yeah, we're done. Although, keep in mind that we didn't do them all the same way. I want you to remember this technique in example 2, where we had to do 2 steps to solve instead of just the multiplication step. We had to do a multiply and a divide. So don't forget that one when you're doing the homework problems.